Algebra Review Part 1. These algebra reviews at the beginning of pre-calculus will just be a hodgepodge of seemingly unrelated topics, but just things that you need to brush up on a little bit before we continue on into the more advanced algebra. So what you'll come upon quite a bit is graphing things on number lines, and so we need to remember what our less thans and greater than symbols look like. The less than symbol sort of looks like a little L that's been tilted over, and then that way that will help you remember L for less than. The little line underneath means it's also equal to, so less than or equal to, and then greater than or equal to. Some textbooks on number lines involving inequalities will use open and closed circles, depending on if you have the equal to line or not. However, I would like you to use parentheses and brackets. This is a good transition into some higher math. So if you have a less than or a greater than without the equal to line, then on the number line that's going to be represented by parentheses. If you have the equal to line, that will be represented by brackets. Also, when describing inequalities whose graph is an arrow continuing forever to the left or forever to the right, we'll be using infinity. On a number line, forever to the left is negative infinity, and forever to the right is positive infinity. We'll be representing inequalities in three different ways. The first way is inequality notation. For example, this first little example, -3 is less than x is less than or equal to 10. The second way is the inequality graphed on a number line. So you can see that the graph starts at -3 and stops at 10. So when you're trying to graph an inequality and the x is in the middle, the number on the left is where you start and the number on the right is where you stop. Because the x is trapped in between those two numbers, your graph runs in between. There's a parentheses on the -3 because it does not have the equal to, a bracket on the 10 because it does have the equal to. And then interval notation is sort of like just taking only this part off of the number line and rewriting it. Our start number is -3, our stop number is 10, a parentheses on the -3, a bracket on the 10. So we're going to take bracket -8, comma 7 parentheses, that is interval notation, and we are going to graph it on a number line and also write it in inequality notation. So first let's do the number line. So I know I'm starting at -8, I'm stopping at 7. The -8 has a bracket, so I'll put a bracket on. The 7 has a parentheses, and then the start is -8, the stop is 7, so we join in between. So that is the number line. And then we also want to do inequality notation. So we have our start number, x in the middle, our stop number, and you will always put less thans for these. Always both symbols are less thans. The 8 has a bracket, so you'll have the equal to. The 7 does not have a bracket, so it just stays the less than. So x is bigger than -8, but smaller than 7. Actually bigger than or equal to -8. Same instructions for this next one. This is interval notation. We want to graph this on a number line. Negative infinity is out here. And then we have 7. So if it starts at negative infinity, it starts forever to the left. It goes forever to the left. And then the stop is at 7, and it's a parentheses. So the graph is going to look like that. Then inequality notation. You want to put your start and your x and your stop, and then it's always less thans. Infinity will never have the little equal to underline, and it will never be a bracket because you can never equal infinity. The 7 is a parenthesis, so it will not have the equal to. When you're dealing with infinities, another way to write this would be simply x is less than 7, because that's implied that it's less than 7 forever. So it would be going to the left forever. Either way is fine for that inequality. The next example starts with inequality notation, and we're asked to rewrite it in interval notation and also graph on the number line. I think it's easier to graph on the number line first and then write it in interval notation. So the number line starts at -2, stops at 6. The -2 does not have an equal to, so parentheses. The 6 does, so bracket. And then the x is trapped in between, so our line runs in between. So there's the number line. And now interval notation, you can just go straight off the number line. Parentheses, start at -2, comma, stop at 6, bracket. Same instructions for x greater than 3. So let's do the number line first. Here's 3. Greater than 3, with all the numbers that are bigger than 3 are to the right of 3. So that would be forever to the right, which is towards positive infinity. And then I don't have an equal to on the greater than symbol, so it's going to be a parentheses. Then we want to do interval notation. So our start is 3, our ending is infinity. Hang on. X in the middle, always less thans. The 3 has a parenthesis, so I don't need the equal to. Infinity can never have an equal to. So there's the interval. Hang on. Let me back up. That is inequality notation. Sorry. So that's inequality notation. It's another way to write what we had originally here. Interval notation, sorry. The start is 3, the stop is infinity, parentheses on both. There we go. The next one only says write in interval notation. You're not asked to draw a number line, but I think it makes it easier if you do draw a number line. So we've got 1. X is less than, so all the numbers less than 1 would go to the left towards negative infinity. And we have the equal to this time, so there's a bracket. And so interval notation, our start is negative infinity, stop is 1, always a parentheses on infinity, and the 1 has a bracket. Now we're completely changing gears, and we're going to do just a variety of little things here. The next thing that will come up in your homework is they're going to ask you about the distance between two numbers on a number line. And so that's just, if the first number is A and the second number is B, you take the second number minus the first number. So it's just that little formula. Also take some time to go back over the exponent rules that are in your book. You've done exponent rules for a lot of different math courses now. Look those over in your book and make sure you've got a grip on those. The ones that what I really want to point out, the most common mistake I see with exponents has to do with how you raise negative numbers to a power, especially in your calculator. If you want the negative to be included in with the exponent, you have to put parentheses around your number. When you're going in the calculator, if you don't put parentheses around the negative, it won't include it. So parentheses -5 squared is positive 25, and that should make sense. If you do -5 squared, that's -5 times -5, which is positive 25. But if you don't have the parentheses, the calculator will simply square the 5 and then stick the negative back out front. So make sure you know which thing you're trying to do and tell the calculator so that it knows whether or not to include the negative. This is a very common mistake. All the time I see that people want this answer, but this is what they put in their calculator. They get a negative number and they don't think anything about it and just go on, when really they needed the positive. So be really careful about that. Rational or fractional exponents come up quite a bit. This is the formula for that. If you have a number or a letter to a fraction power, you can change that to radical form by putting the number on top of the fraction under the radical. The number on the bottom goes on the outside. It depends on the type of problem which form is best, and you'll know when we get to do those. But just to simplify this, if I want to evaluate 32 to the power of 3/4, then I will need to write it in radical form. The 4, the denominator, goes on the outside of the radical. The cubed goes on the inside. So that's the 4th root of 32 cubed. 32 cubed means we're doing 32 times itself 3 times. Now there are multiple ways to simplify radicals. I'll just show you the way I do it, but if you do it a different way, especially if you can take some shortcuts in your head, that is fine. But this is the not shortcut way. So after I spread out my 32s, then I'm going to break down 32, and you can break it down however you can think of first. The first thing I think of 32 is 4 times 8, and so we're going to have that every time. Then the 4 will break down 2 times 2, and that's the end of those branches. I like to do little underlines. 8 is 2 times 4, and then that 4 will break down again. And then that's going to happen all over again on the other two 32s. And I like to think of the little radical symbol as a house. And if you have the right number of friends, you can come out of the house. If you don't have the right number of friends, you have to stay home. So how you know how many friends you need is the little number right here, 4. There has to be 4 of the same number for that number to get to come out of the house. So here I have 4 2s, so a 2 can come out. And you only look at the numbers that are at the ends of the branches that I've underlined. Here's 4 more 2s, so another 2 can come out. 4 more 2s, another 2 can come out. Then these 3, there's not enough, so they'll have to stay home. If more than one number comes out, you multiply them. So on the outside of the house will be 2 times 2 is 4 times 2 is 8. And then it's the 4th root. Staying inside, multiply 2 times 2 is 4 times 2 is 8. So the simplified version is 8, 4th root of 8. And sometimes that's a preferable form than just putting in the calculator and getting the decimal, because the decimal has to be rounded, which is more inaccurate. You are adding and subtracting with radicals. You can only add and subtract if they are like radicals. So right now, square root of 27 plus square root of 300, we can't do anything with that, but we can break those down. So square root of 27 plus square root of 300, and we'll do our factor trees. 27 is 3 times 9, and then 9 is 3 times 3. 300 is 3 times 100. 100 is 10 times 10. Now I'm going to stop with those 10s because this is a square root. I only need 2 of the same number for that number to get to come out. So since I have 2 10s, I don't need to break those down any further. So they're friends. This 10 gets to come out. These guys are friends, so a 3 comes out. This 3 is by itself, so it has to stay home. And this 3 is by itself, so it has to stay home. So we end up with, in the first one, a 3 is out, and then a 3 stays home. On the other one, a 10 is out, and a 3 stays home. Now they're the same. They're both square root 3, and you can add the outside numbers. 3 plus 10 is 13, square root 3. And then the final topic for this little algebra review is scientific notation. Again, you can look at your textbook to kind of go back over that. I've just got some examples here. Scientific notation always has a decimal after the first non-zero number, and then it's times 10 to some power. Large numbers, which would be this first one and then this one, large numbers will result in a positive exponent on the 10. So if I'm converting from scientific to decimal, 3.45 times 10 to the fifth, since that represents a large number, to make my number larger, the decimal would go to the right. So I move the decimal right 5 places and fill in with zeros. 3.45 times 10 to the negative 5, negative exponents mean my number is going to get smaller, so the decimal would have to move to the left. So it started after the 3 and it moved 1, 2, 3, 4, 5 to the left and fill in zeros. Going the other way around, 4,390,000 is a large number. I know my decimal needs to go after the 4, after the first non-zero number. It is back here invisible. So to get it after the 4, I would have to move it 1, 2, 3, 4, 5, 6 places. And because it's a large number, it's a positive 6. And then moving my decimal for the last example to after the 7, 1, 2, 3, 4, 5, 6, 7 places, and it's a negative 7 because I'm dealing with a small number.